Hello everyone, welcome to my channel C.S.E-Pathshala. In this tutorial, we are going to study about Introduction to Deep Learning. So if I talk about deep learning, it is a subset of machine learning and basically it is based upon conventional artificial neural networks. So what do we mean by artificial neural network? Let's first discuss about a neuron. See, if we want to create an artificial neural network, there will be a connection based upon a neuron. Okay, because ANN or artificial neural network is similar to biological brain network of the human body, and it also consists of a layered architecture as like of the brain network, and every node or a connection point here that is called as a neuron, which is being capable enough to perform the processing input, whatever we give to it for the processing or for the calculations or for the computations, and it performs the transmission of the output to the other nodes. So basically there is a network. This network is interconnected with the neurons. Neurons are the computing elements, and in these computing elements, we used to give the inputs, that is the data, for the processing. Okay, so here basically we are available with the input layer. Input layer consists of the initial data which we give to the neural network for the computation. Then there are intermediate layers, or they are called as the hidden layers, and this layer is between your input layer and the output layer. Okay, and all types of computations is been done inside these layers only. Then comes the output layer, where we basically produce the results for the inputs which we have given for the computation. Okay, so these three layers are available in your artificial neural network. Okay, so that is your input layer, output layer, and hidden layer. Okay, so if you talk about the conventional artificial neural network, they only comprises of one hidden layer or one computational layer only. Okay, and here the point is, since they are only having one layer of hidden, so definitely the complexity is less. Okay, and the computations are that much not enough to perform any hardcore task. Okay, so what happens is, if we go through to the current uh, time or the current analysis, we have improved the performance of artificial neural network. And now what we are going to have is input layer, output layer, and several hidden layers. Okay, so this all makes a deep learning neural network. Okay, so if I show you the diagram for the conventional artificial neural network and the deep learning neural network, so here it is. You can see that only one hidden layer is been present here for the conventional neural network. Okay, and if I talk about the input layer, here is the input layer. Okay, where we give the input in the form of x1, x2, x3, and the circles which you are seeing here are the neurons. Okay, so basically here it is an interconnected network where all the neurons are connected. Okay, and this is the hidden layer where the computation has been performed. Now only one hidden layer is present. Now if we talk about this architecture of the deep neural network, here multiple hidden layers are present, and all the computation has been performed here. So x1, x2, x3, these are all the inputs. W1, B1, these are the weight and the bias. Okay, so we can see that W1, B1, then W2, B2, W3, B3, W4, B4, these all are the weight and or the bias which are present in the intermediate layers. Okay, and this is Y3 and the Y4, these are the output which are produced on the output layer. Okay, so now this is the architecture for the deep learning networks, neural networks, and Generally, deep learning neural networks are divided into two categories. These two categories are convolution neural networks and recurrent neural networks. So, what are these? If you talk about convolution neural networks, these networks are mainly created for performing the computation over the images. Okay, and if you talk about the recurrent neural network, they are mainly used for performing computations over the sequence data, text, and the time series. Okay, so now the point is we focus upon the timeline of the deep learning. Okay, how it has came into your analysis in your studies and where we are currently. Okay, so in 1989, Yan and his colleagues, they proposed a CNN, that is convolution neural network, that is called as LENET. Okay, this LENET was successfully used for performing the recognition over handwritten digits. Okay, so in 1989 only it has been introduced. Now, in the upcoming years, if I talk about 2010, the Professor Lee of Stanford University created ImageNet. Okay, and this ImageNet is basically it's a huge database. It comprises of more than 14 million images of daily objects. For example, if I talk about cats, dogs, cars, tables, chairs, and so on, about 20,000 category of objects has been available in the form of an images in the ImageNet. Okay, and ImageNet then launched a challenge, an annual challenge based upon the image classification. Okay, that is called as ImageNet Large Scale Visual Recognition Challenge. Okay, and that challenge used about somehow about 1,000 categories, and this particular competition it ran from the years 2010 to 2017, and then it moved to the Kaggle. Okay, the Kaggle website after 2017. Okay, so the huge breakthrough has been found in the year 2010 by Professor Lee by creating the ImageNet. Then another breakthrough has been made possible by Alex. Okay, and Alex and his team created AlexNet in 2012, and which produced an excellent top 5 accuracy, that is 85%. Okay, so it took the first place in the contest for this. Okay, and then the next best outcome which has been produced, that is was 74%, which was after that. Okay, so the AlexNet has got the highest accuracy, that is the 85% accuracy for your images classification. Okay, so what does this top accuracy means basically? If we talk about top one, see, top one accuracy is the best prediction match with respect to the result which we are anticipating, the result which has been expected that this should be the correct or the true answer. So this AlexNet, if I just talk about 85%, it has been correct. So top one accuracy means the highest prediction, the best prediction which we got for the expected result. Okay, top five accuracy means the top five, results. Okay, the top five likelihood results which we get, or the top five responses which we get that matches with the predicted response. Okay, now the depth of the model which has been created by the AlexNet has a very good primary results, and however, the results are good, but here the computations or the calculations are quite expensive because there is a use of GPUs. Okay, that is graphics processing units. Okay, see, as I already told that deep learning comprises of many intermediate hidden layers, and all the computation has been performed on the hidden layers. Okay, since there are multiple hidden layers, definitely the computation will be more. Okay, so if we are going to perform the computation over the local machine with limited resources, then obviously it will take some time, and you know, we have to take care of the resources also. But however, if we are taking some external resources for the computations, for example, GPUs, that is graphics processing units, then it can make the task simple. Okay. Now, next, what happened is another work has been done by Joffrey and his team, and they are basically called as the godfathers of artificial intelligence or the godfathers of deep learning. So the scientist named Geoffrey Yan and a computer scientist from the Canada, that is Joshua. Okay, they are called as the godfathers of AI. Okay, in 2014, now the Google came, and Google has created its own model for the image classification, that is a Google Net. Okay, that uses another technique or another algorithm that is called as inception. Okay, so inception module or inception architecture, whatever we can say, it has performed the object detection. Okay, because obviously we are available with millions of images of different objects. Now we are using the model which has been created by these organizations to perform the detection of the objects. Okay, so in 2014, Google has created GoogleNet, and on the basis of that, there was a research paper published that was called as Going Deeper with Convolutions. Okay, this methodology has been discussed in the paper. Okay, and the closest neural network comparable is the GoogleNet, which has top 5 error rate of 6.66%. Okay, so Google Linet, and that is the closest neural network to the Google Net. Okay, and it is having your 6.66% top 5 error rate. Okay, and as been told, it's been called as inception. So we are having different inception models also. Inception V2, inception V1. Okay, starting from the V1, inception V1, inception V2, inception V3, and so on. Okay, so there are various versions. Now next, then came the VGG model. Okay, that is visual geometric graph. Okay, so another scientist, that is Karen and Andrew from the Oxford. Okay, they did worked upon the VGG. Okay, and they performed the image categorization or the classification and the localization. Okay, and here the error rate was 7.3%. Okay, so VGG comes in the second, and we are also having a different VGG models also. For example, VGG 16, VGG 19. Okay, so these are certainly the versions where there is a change in the architecture. Okay, and on the basis of these algorithms, we are performing various other tasks for the deep learning. Okay, so here the classification error rate was 5.1%. Okay, then from the Microsoft research, they did develop an excellent algorithm for object detection. Okay, and with some localization test, that is ResNet. Okay, so ResNet, it surpassed all the picture classification and the identification technique which happened till that particular time, and it is having a top 5 error rate of about 3.7% only. Okay, so now we can see that the error rate, the Google Net error rate was 6.66%. Okay, for the image classification. VGG model was having an error rate of 5.1% for the image classification, and now ResNet has surpassed all these techniques, and its error rate is only just 3.7%. Okay, and later on in 2019, Efficient Net, okay, which has been considered as a top 5 classification. Its accuracy was 97% for classifying the images. Okay, so as we go on further till 2019, this is the data or this is the timeline available with me. Now there are much more techniques or algorithms has came for the image classification, object detection. Okay, and they are continuously improving on. Okay, for example, we are now having YOLO, that is you only look once. Okay, these object detection techniques. So we are having YOLO 3, 4, 5, 6, and 7 version also. Okay, so a lot of work has been done on the basis of your computer vision. Okay, so here is the image classification graph on the ImageNet. Okay, starting from the LXNet, then it moves to the Inception V2, Inception V3, then ArsNet, and so on. Okay. Now, if you talk about the classical or the traditional machine learning algorithms, these methods are, they work upon a very limited amount of data. Okay, right now, as we are in a trend of big data, so obviously we need to perform the computation over that data, which is having multiple features and which is lengthy in nature. Okay, so here the volume of data has now reached to the millions. Okay, and their performance and their level of data volume has been growing continuously. So obviously, we need to use such technique which will tackle that particular or a huge amount of data and perform the analysis and give you a better performance, better results, high accuracy. Okay, for that purpose, we are in a demand of using deep learning techniques. So now our neural network, which was previously just with the three layers, that is input layer, hidden layer, one hidden layer, that is, and one output layer. Now we are having an improved architecture which comprises of an input layer, output layer, and multiple hidden layers. Okay, because we need to train, we need to perform computation over our data. Okay, so this requires multiple times of training, so that our neurons get high level of understanding that okay, if this has been fed, this should be the results. Okay, so on the basis of that, we are now working with the deep learning. So deep learning neural network are receiving a lot of study, lot of research has been going on. As I already told that many algorithms has also now been developed. Either we are working in the field of computer vision, either we are working in the field of natural language processing. We are having lot of scope in case of deep learning. So here, if you talk about the performance of deep learning is obviously better than the machine learning and traditional artificial neural networks, because here the point is we have in depth, we have in core enhance our architecture. Okay, we have introduced multiple layers, so these layers, the training or the computation has been performed, and obviously we are going to have improved results. Okay, so this is a general introduction of deep learning, and in the next tutorials we are going to study further about the deep learning topics. Okay, so thank you very much.